today, we're starting today, chapter 5, and chapter 5 is about trying to understand electrons and behavior of electrons. In order to do that, we are going to go through historical development of our understanding of atomic structure, periodic table, and structure of the electrons. So Mendeleev, who was studying the properties of different elements, he decided to place elements which behave alike and having the same property in the same column. And when he did that, he observed that there is a pattern in going from one column into another column. And he decided to order the elements in a table based on their atomic weight. Atomic number at the time was not known, but atomic weight was known. So based on that, he was able to come up with different columns of similar behaving substances, and he ordered them in order of increasing atomic number, atomic weight, 7, then 9.5, then 11, then 12, then 14. So he is organizing his table based on increase of atomic weight in AMU. This was very successful. By making this table, he came up with two spaces where there was no element to fill these two spaces, yet he thought there is going to be these elements discovered, and once we discovered, we can study their property. But by analogy of the elements in the same column, he was able to predict that this element, atomic weight of 68, is going to behave like aluminum, and the element atomic weight 72 is going to behave like silicon. So he called this future element eka silicon, which means the element which is under silicon. This other one was called eka aluminum, the element which is going to be under aluminum. It didn't take very long where these two elements were discovered, and he really met his prediction. This is the eka aluminum, look at it. It was called gallium. Mendeleev's prediction was that when this element is discovered, the atomic weight is going to be 68 atomic mass unit, and the real atomic weight of the discovered element was 69.72 atomic mass unit, so quite close. And he predicted the density of the density of gallium to be 5.9 grams per cubic centimeter. It really ended up to be 5.91 gram per cubic centimeter, so very close to his prediction. He said this element, when discovered, it must have a low melting point. Well, when discovered, it was realized that gallium has a melting point of 29.8, very close to room temperature. Room temperature is 25 degrees Celsius. This is only few degrees above room temperature. His prediction was that if you react this element, it will give you a product. If you react it with oxygen, it will give you a product which is going to be metal 2 times oxygen 3, and that's what happened after discovery of gallium. When it's reacted with oxygen, it produced Ga2O3. His prediction was that this new element must react with chlorine, just like aluminum. Aluminum reacts with chlorine to give you AlCl3. He said the product of reaction of this unknown element with chlorine must be XCl3. Yes, that's exactly what gallium showed to react with chlorine and produce gallium chloride. And as far as the mass is concerned, he expected a mass of 72 atomic mass unit. The actual one was 72.61 atomic mass unit. And this is for what it was called. It used to be called ecosilicon, but it was the element when discovered was named germanium. So germanium had a mass of 72.61 AMU. Mendeleev had predicted 72, quite close. Density was predicted to be 5.5 gram per cubic centimeter. It ended up to be 5.35 gram per cubic centimeter. Mendeleev had predicted a dark gray color for germanium, and germanium has a light gray color. And his prediction, Mendeleev prediction of reaction of this element with oxygen should give you XO2, where X is that metal, symbol of the metal. In reality, germanium reacted with oxygen to give you GeO2, exactly the same as Mendeleev predicted. And he said this element reacts with chlorine and give you one atom of metal connected to 4 atoms of chlorine. So the formula should be GeCl4. That's exactly what happened. But Mendeleev found something wrong with his table. The thing which was wrong was the fact that mass, atomic mass of argon was 39.95, atomic mass of potassium 39.10. So argon was supposed to be next to potassium on the right. We know potassium is a very reactive metal, and we know argon is not reactive at all. It's a noble gas. It's not reacting. Based on his table, argon was supposed to be reactive. So he realized there is something wrong with his table. And this problem was not resolved until 40 years later, when electrons were discovered, where atomic number were discovered, and the table was organized based on increasing atomic number, not based on mass number. I want to refresh your memory from something we discussed in Chem 2A. Remember, J.J. Thomson got a Nobel Prize in 1906 for discovering that atoms are made out of electrons. What was his discovery? His discovery was based on the experiment that he had with cathode ray tube. Now, what's cathode ray tube? If you apply a voltage across two metals, as a result of the potential energy of the battery and high voltage, you are going to see this metal losing electrons. Electrons are attracted toward this positively charged plate, and electrons hitting a fluorescence screen, and the fluorescence screen started glowing. So that is the discovery which resulted to the fact that this metal is made out of atoms. Atoms must be made out of electrons. Electrons have negative charge. How did J.J. Thomson prove that electrons have negative charge? You see, they were repelled by negative terminal, attracted by positive terminal. So point B moved to point C when the electric field was placed across this ray. He also did another experiment. He brought a magnet around the ray was deflected. Now, why? Well, you probably remember we said whenever electrical charge moves, it creates magnetic field. So electrons have negative charge. Moving negative charge produces magnetic field. The two magnets interacted together, so the ray was deflected. So this is just a little refreshment for you to remember what cathode ray was. Now, in 1913, Moseley used cathode ray. And when he applied cathode ray to elements, he noticed the elements emitted X-ray. And when he measured the frequency of the X-ray, which was generated by the use of cathode ray, he came up with a formula where the frequency is depending on a value. He called it Z, and he was able to prove that Z is atomic number. So it's 1913, atomic number for elements have been discovered by this experiment by Moseley. So after that, scientists decide to resolve the problem of periodic table of Mendeleev by simply reorganizing elements and placing them in the order of increasing atomic number. And this table, argon is here, far away from potassium, which is very reactive metal, and argon is non-reactive, non-metal. It's a noble gas. So every experiment we have done since then has shown that periodic table is showing periodicity. It's showing property, relative prediction of the properties of element. For example, one of the periodicity is that in periodic table, as you go down the table, atoms are getting larger. And inside the period, if you move from left to right, atoms are getting smaller. And this will affect properties of atoms and elements. And we will probably discuss this later. Now, on this slide, what you see inside the column, do you see the atoms are getting larger as we go down the column? And inside the period, if I go from left to right, atoms are getting smaller. So again, showing the periodic properties of atoms. So if I go to the next slide, what you see is the same pattern. Do you see as I move from lithium to fluorine, as I move from lithium to fluorine, do you see that size of the atoms are decreasing? This is the size of lithium, which is on second period. And the size of the nucleus is 150 picometer. And as I move to the left, I get to fluorine. That atom, the size of the fluorine is around, let's say 65, 70 picometer. So again, you see the same thing for the third period. As I move from left to right, atoms are getting smaller. Fourth period, starting from potassium, going to bromine, atoms are getting smaller. So you see the periodic pattern in periodic table, and that's why this table is called periodic table. It predicts the properties of substances based on location in periodic table. What column is it? Which period is it? Then you can have some prediction about the property of the element.